I'm going to do a series of videos going through the higher applications of mathematics specimen papers. Now be aware that these specimen papers sometimes are a little odd. I think at the beginning of a new course they are really trying to show the potential of the new course with all the interesting questions they can come up with, and sometimes they go a bit far. However, most of this is good for us to look at. So let's have a quick look through it. Title page, everything you would normally have. Forename, surname, date of birth, candidate number. Now immediately here receive total marks, 80. Later on they reduced this to 65 marks. I'm not really sure why, but they made it a shorter exam. On the inside page you've got a list of the electronic files that you should have provided to you on the computer, and also a list of all the printing that you need to do. If you've done these questions, you can use this to check you've done the printing that you should have done, and make sure you hand in all of this printing. So in question 1 we're dealing with an activity network, which is slightly different to the PERT chart that you might normally get in a higher applications of mathematics paper. You would normally have activity networks in National 5 applications of maths. Now this is a specimen paper, so we may expect some weirdness, but most of this question is relevant for us. So in question A we are asked to state the definition of a critical path. The marking scheme says the path through the project that allows the sequence of tasks that allows the project to take place in the shortest time. Now I'm not sure that is completely correct and what you would actually need to say, because they do revise how things are marked from year to year. When you work out the critical path, it is the longest time from start to finish, and it tells you how long it will take to do the entire project. So I think you could say something like this, that it's the path from the start to the finish that takes the longest time, and it does tell you how long the project will take. Each task on the critical path is a critical task, which means that the float time is 0. In other words, any of these tasks cannot be delayed, otherwise the entire project would be delayed. Okay, so now we're on to part 2, determine the critical path. So we'll have to start at A and finish at H, and we need to find the tasks in between that take the longest time. So the top route would be B, E and G, so 8 plus 1 plus 2 would be 11. Central route, 3 plus 2 plus 2 would only be 7, and the bottom route would be 10. So the fastest route is A, B, the longest route is A, B, E, G and H, and that is our critical path. And you just simply write the letters of the tasks in order. So now we're on to part B, where we need to find the completion date, the earliest possible completion date, if the start date is Monday the 3rd of February. So we'll first of all find out how long the task will take by adding up the tasks on the critical path. So in this case it's 2 plus 8 plus 1 plus 2 plus 4, so 17 working days. We'll get some space here. Starting on Monday the 3rd of February, we'll work forward a week at a time. So Monday the 10th of February, that's only 5 working days later, because we don't count Saturday and Sunday, although you do add on 7 to get a week later, the date. That's 5, that's another 5 to the 17th of February, and another 5 to the 24th of February. Now that's in total 15 working days, and then we need to have 2 extra days, and the task will be finished on Wednesday the 26th of February. Now this is potentially something to trip you up. The project will actually be finished at the end of Tuesday the 25th of February. So if we include Monday and Tuesday as work days, by the end of Tuesday, that's 2 days have passed. So the actual completion date is the Tuesday, the 25th of February. So now we're on to question C. Calculate the maximum number of days that activity C could be delayed without delaying the end of the project. So let's have a quick look back at the activity network. We can see that activity C and F carry on in parallel to B and E, which are on the critical path. So B and E together will take 9 days. That's what limits the project completion date. C and F together are only 5 days. So there's 9 take away 5, which is 4 spare days there that either C or F could be delayed. In this case, it's C that might be delayed. So we will do 8 plus 1 is 9. That's on the critical path. And then C and F, 5 days together. And 9 take away 5 is 4 days slack time that we could have a delay in activity C. So now on question D. Activity D involves the hiring of equipment to be used, but it's also used on activity H. When would you advise that this activity is started? Now for a start, it's not worded well. This activity, I believe, refers to activity D, but you can see this question paper hasn't perhaps had the same scrutiny that an official exam paper might have had. So this is a complication that is possible that may be introduced into a PERT chart or a Gantt chart or an activity network question with resources being used for various activities in the project. So let's have a look back at the finish date. Now we said the project would finish at the end of 25th of February, but for our calculations we'll use the 26th of February as the end date, and there's a reason for that, which I'll tell you in a minute. We will need to work backwards a certain number of days from the end. So imagine we need the equipment for 1 day before the end. Well, then you would be needing the equipment on the beginning of the 25th of February, which would be 1 day before the 26th of February. So we need this equipment at the beginning of activity D. So we need it 10 plus 4 equals 14 days before the end of the project. So we will work out the end of the project date, 26th of February, then minus 14 days. And that will give us the latest possible date that we can get away with hiring this equipment. So 26th of February, take away 14 working days. And again, with the working days only being 5 days in a week, it can be a little tricky. So I advise work back 5 days at a time, week by week. And it is potentially something that might happen in your exam. So that is 2 weeks, brings you to the Wednesday the 12th. Then we need to work back 4 extra days. So again, we're over a weekend. So to Monday, that is minus 2 days, and another minus 1 day to get you to Friday, and another minus 1 day to get you to Thursday. So advise you start the activity on Thursday the 6th of February. This is potentially something that you could have to write a bit more to justify your answer. So the reason that you would want not to start this any earlier is because there may be a charge for hiring the equipment. So by hiring the equipment as late as possible, you're saving money on hiring it. And I've made a mistake there. I've said Thursday the 6th of March. Should have been Thursday the 6th of February. Remember, in the exam, you do have access to a computer, so you can look at the calendar if you're using Microsoft Windows or another operating system with a calendar on it. So I've pasted in a calendar here, and you can see I've highlighted the tasks before the end date. So we said the end date was the beginning of Wednesday the 26th of February. Working back 4 working days for activity H gives you the highlighted dates there in green starting at the 20th of February. And then you have 10 working days which I've highlighted in yellow to show that the earliest date is the 6th of February that we need this equipment. And I think for this kind of working with dates, it would be very easy to get it wrong by 1 day or 2. So that is probably something you should do, is look at the calendar on the computer. In this case, it didn't tell you the year, so I had to look at which year actually had the right days in February. And that was 2020. But you can easily go back and forth and try and find an appropriate year to use.